can solve division word problems with remainders. Tyler planted potatoes, oats, and corn. There were 23 acres planted with potatoes. There were 3 times as many acres planted with oats as potatoes and 4 times as many acres planted with corn as oats. How many acres did he plant with potatoes, oats, and corn in all? Now our key word here is keywords in all. That means you're going to have something like this, and as always we start out with the unknown, so we'll put an A representing in all. And what does that represent? We can call this a what? What is it? It's a variable. Go ahead and pause and try to work this problem out. Make sure you read it again and highlight all the important information. Okay, so we know that he had 23 acres with potatoes. And there were 3 times as many acres planted with oats as potatoes. So we have, this is our oats, this is our potatoes, and then we have corn. Now, interesting, the different thing about this that we haven't seen in the past is that now we have 4 times the second amount we found. So we're going to have 4 times as much corn as we had oats. But before we can do anything, we got to find out how many oats we have. So for oats, you're going to take 23 times 3, and then whatever your oats is, then you're going to take that times 4. How do you find out how many in all? What do you have to do? You have to add all 3 together. Let's find the quotient by counting on our fingers. Why is quotient in red? That's because that's a word you need to know. Quotient. What does the word quotient mean? Any ideas? Sum is the answer to an addition problem. Difference is an answer to a subtraction problem. Product is an answer to a multiplication problem. Quotient is the answer to what kind of problem? Division problem. Now, I know you're used to seeing like 12 divided by 2 with this symbol here, but there's another way to show division, and that's with a slash. So this also says 12 divided by 2. And we're going to do the slash because when you get to fractions, it'll make it a lot easier to visualize, because a fraction is really just a division problem. You could look at it as a division problem. So go ahead and you're going to count by 2's to get from 2 to 12 and use your fingers. So if you start on your left hand counting, you count by 2's, it's 2, 4, 6, 8, 10, 12. How many fingers did you just count? You should have counted 6, because then you'll see that 6 times 2 equals 12. So go ahead and pause. And solve the rest of the problems, and then when you're done, you're going to talk about what the pattern is that you are seeing as you divide and count by 2's, 3's, 5's, 4's. Okay? Okay, let's look at these boxes. How many boxes do you see all together? Let's count each column by 3's to check. So, why would we count each column by 3's? This is a column right here. How many boxes are in each column? There's 3 boxes. So when you see there's 3 boxes, you'd count by 3's. If I want to count the rows, I would count by 4's, because there's 4 boxes in each row. But first, let's see how many boxes we have all together. We have 1, 2, 3, 6, 7, 8, 9, 10, 11, 12. 12 boxes altogether. Let's count each column by threes. So you have, let me change my color here. You have, let's do that color. 3, 6, 9, 12. We can also count each row by fours to check. Now the nice thing about counting by fours, I've already numbered each row. So there's 1 through 4 in each row. So we can quickly count by fours on this. We don't even have to add on our fingers. If you don't know your facts, 4, 8, 12. Write 2 multiplication sentences to show how many boxes are in this array. We just counted rows, so we could take the rows times the columns, or we could take the columns times the rows. However you want to work it. Because we're going to do 2 multiplication sentences. So we can say 3 columns. Actually, there's 4 columns. 3 rows times 4, because there's 4 in each row, equals 12. Is that a multiplication sentence? Yes, it is. And then we could say 4 columns, and how many are in each column? 3. So 4 times 3 equals 12. And now the last one, it says write 2 division sentences for this array. So I could take the 12 and I can divide it by 3 rows, and that gives me 4 in each row. Or I could take 12 boxes and I could divide it by 4 columns and have 3 boxes in each column. Pretty easy stuff. And remember, another way to write your division sign, oops, I erased part of my 12 too, is just by doing like that, okay? And that's what you're going to be seeing, so you kind of get used to seeing it as a fraction and a division problem. Also, I don't know how to insert the division symbols on my PowerPoint, so someday I'll figure that out. Okay, how many boxes do you see all together? So go ahead and count them. How many do you see? Let's count each column by twos to check. So we're going to count by twos. 2, 4, 6, 8, 10. Let's count by rows to check. How many are in each row? There's 5 in each row. So 5, 10. We're counting by 5s. Write 2 multiplication sentences to show how many boxes are in this array. Well, so we have 2 rows times how many in each row? How many boxes are in each row? 5 equals 10 boxes. We also have 5 columns. And how many are in each column? There's 2 in each column, and that equals 10 as well. Now you're going to write 2 division sentences for this array. So we're going to start with 10 boxes, and if we divide them by 5 rows, 5 columns, and we have 2 in each column. So 10 divided by 5 is 2. We could also say 10 divided by 2 rows of 5 equals 5 in each row. So 10 divided by 2 would be 5 in each row. Okay, you go ahead and see if you can solve this one, and then we'll go over it. So pause it and go over it. Okay, how many boxes do you see altogether? There are 21. Let's count each column by threes to check. So we have 3, 6, 9, 12, 15, 18, 21. Okay, let's count each row by sevens to check. 7, 14, 21. So we know we have 21 boxes, and it's made up of 7 columns, 3 rows. So 7 times 3 is 21. Let's go ahead and write that multiplication sentence down. 7 times 3 equals 21. You could also say we have 3 rows times 7 in each row equals 21. Let's think about division. 21 divided by 3 rows equals 7, because I have 7 in each row. 21 divided by 7 equals, that's 7 columns, equals 3 in each column. It's pretty easy stuff if you ask me. How many groups of 2 are in 10? Let's prove it by counting by 2's. Use your fingers as you count. Show and say how many groups of 2 are in 10. So, hold your fingers, hold your hand up, and count on your fingers. 2, 4, 6, 8, 10. How many fingers are you holding up? 5 fingers, so there are 5 groups of 2 in 10. Okay? How many groups of 2 are in 11? Count with me. 2, 4, 6, 8, 10, 12. Oh, we can't do 12, so we know it's not 6, because if we do 6, we go over 1 too many. So, how many groups of 2 are in 11? Well, there's 5, because I held up 5 fingers. There's 5 groups with 1, so 5 groups. There's 5 groups of 2 and 11, and then I end up with 1 left over. So let's look at these. 8 divided by 4. Well, count by 4s. 4, 8. How many groups do you have? I have 2 fingers held up, so I have 2 groups. How many are left over? 0. Okay, let's count by 4s again, because we have 9 divided by 4. 4, 8, 12. Oh, that doesn't work. So let's go back. 4, 8. I have 2 fingers held up, so I have 2 groups. How many are left over? Well, how many do I have to go from 8 to 9? I have to go 1 more, so there's 1 left over. So go ahead and pause and fill in the rest of the chart. Once you're done, move on. There are 12 students in PE class, separated into 4 teams. How many students are on each team? Read the prompt and draw an array to represent the division problem. Tell me the division expression that matches the situation. So, Whoops, I don't want to go past that. Go ahead and pause and see if you can draw an array to match. Now, the array is, remember you have rows and columns that equal, well in this case, you're going to have rows and columns that equal 12. 12 boxes once you're done. So, go ahead and pause and then write the division sentence that matches, or the division expression. Okay, so here's how I did it. You can do boxes or you can do circles. Either way is fine. If you notice, I have 4 teams. That leaves me with 3 rows. 4 times 3 is 12, so that works. What is a quotient? Well, first of all, what is quotient? What does that word mean? We talked about it a little bit ago. What does the word quotient mean? Okay, quotient is the answer to a division problem. So how many students are on each team? Well, we want 4 teams. That was the whole goal. The goal is to have 4 teams. So we have our 4 teams. Now, how many are on each team? Well, you can look at it like the columns we did a little bit ago. Each team is a column. How many players are in each column? 3. How can you check to make sure your division is correct? Well, I could take 4 columns times the 3, so 4 teams times the 3 players in each team. 4 times 3 is 12. So what you do is you multiply, do the opposite. So when you divide, you multiply to check to see if you're correct. Now, does a quotient tell us the size of the group or the number of groups? What does a quotient tell us? In this case, it tells us the size of the group. Because the question is, how many on each team? Well, we already know the groups. We know that there's 4 groups, but we don't know how many are in each group. We know we have 12 kids. We know we have 4 teams. The question is, how many are in each group? So the quotient tells us the size of the group or number of groups. So 12, this is a division statement. 12 divided by 4 equals 3, because I'm going to divide it by 4 teams. That would give me 3 kids in each team. Okay, how can you check to make sure your division was correct? Does this quotient tell us the size of the group or the number of the group? The same array can represent a situation with the group size unknown or number of groups unknown. So let's revise this story a bit. Again, we have 12 students in PE, but now 3 students are needed on each team. How many teams can be made? So I'm going to go in, I'm just going to circle every 3 students. That's the best thing about the arrays. You have the picture. You don't really have to do anything. You just draw 12 dots, and now we have 3 students, so we do it by 3s. And I'm just going to go in and say, okay, there's 3, there's 3, 3, 3. How many teams can be made? What is the division expression for this new story? Well, it would still be 12, but it's 12 divided by 3, because we know we have 3 students in each team. 12 divided by 3 equals how many groups? 4 groups. How can I check my work? Take this times that, and it should equal that. Okay. There are 12 students in PE class, separated into 4 teams. How many students are on each team? One more student joined the class. There are now 13 students to be divided into 4 teams. Draw an array to find how many students are on each team. So go ahead and pause and draw your array and then continue when you're ready. Okay, I think I'm going to go back to the previous slide and draw an array to show you what that would look like. So we have 12 total students in 4 teams. So I'm going to go by 4s. I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. My problem is, so we know now we have 3 students on each team. But my problem is that one more has joined. There are now 13 students to be divided into 4 teams. So obviously, we have 3 on each team. We don't want to leave the other one out, so we're just going to group them in a team. But what you would say typically is you would have 3 remainder one. Okay, what is the quotient? There's that word quotient again. So what was the quotient? The quotient was 3. So it's the answer to our division problem. We took 12 divided by 4 equals 3, or actually 13 divided by 4 equals 3, remainder 1. So what is the leftover amount? What's the remainder? 1. We state our answer by saying the quotient and then the remainder. The quotient is 3. The remainder is 1. We can also say or write the quotient is 3 with a remainder of 1. Okay, let's look at the story again. There are 13 students in PE class. 3 students are needed on each team. How many teams can be made? Tell me the new expression. So what is the new division expression for this problem? We know that we have 13 students. We need 3 on each team, so divide by 3 equals, well, we're going to divide by 3. There's a group of 3, there's a group of 3, group of 3, group of 3, can't make another group, so I have 4 groups of 3, remainder 1. What do the quotient and remainder mean this time? What does the 4 represent in this case? 4 represents the number of groups. And remainder 1 represents that poor kid who didn't quite make the team. This is a number bond with the quotient and the remainder. So I have 13 students total. So 13 total. What do I have to add it together to make 13? Well, 12 and 1. And we know that we have 4 groups of 3, so 4 times 3 is 12. That doesn't give us our answer, so we have to add 1 more. Christy bought 13 roses. If she puts 6 roses in each vase, how many vases will she use? Will there be any roses left over? Draw an array. Solve for 13 divided by 6. Write a statement that tells the quotient and remainder for this problem. So go ahead, pause. We know that your array is going to have 13 dots in it, and we know it's going to have either 6 columns or 6 rows. So go ahead and solve. Okay, so the way I would do this is I would have 13 divided by 6. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 divided by, well, divided by 6 equals how many groups? So 13 divided by 6 equals 2, remainder 1. It's easy, easy people, easy. Okay, so there will be 1 rows left over. She'll use 2 vases with 1 rows left over. Let's revise our story a bit. Now Christy bought 13 roses and wants to put them in 2 vases. How many roses will be in each vase? Is this the same array? So go ahead, pause, and see if you can figure this one out. Okay, if I were solving this, I would say we have 13 roses, 2 vases. So I'm going to have 2 in each row because those are going to represent my vases. So I'm going to go by 2s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have our 13 roses, we have our 2 vases. How many roses will be in each vase? Well, let's look. There's vase 1. There is vase 2. So we have 1, 2, 3, 4, 5, 6. 6 roses in each with 1 rose left over. Is this the same array? Well, let's look. It is the same, but one is vertical and the other is horizontal because you're using a different number sentence, but do you have the same answer? Yes. You still get 13 roses. But in this case, you have 6 roses in each vase. In the other case, you have 2 vases with 1 left over. So how's the interpretation of the array changed, and how can we check our work for both? In the first story, we didn't know the number of vases. In the second story, we didn't know the number in each vase. We changed the story from finding the number of groups to finding the size of the group. So how can we check our work? Well, to check our work, let's go back to this. You can say you take these 2. This is your quotient and your divisor, and you multiply them. So it gets me 12. Now when you multiply, it should equal this number here. But as you see, I have 12 and this is 13. What do I need to do now? What do you think is my next step that I need to do? I multiply the quotient and the divisor, and it's supposed to equal the dividend. This is a dividend, but I didn't get that answer. So what do I need? What am I missing? I need to add the 1 to it, my remainder. So 12 plus 1 equals 13. Is this my dividend? Yes, it is. That means it's correct. Let's check this one. We have 6 roses, so 6 in each vase, so 2 vases equals 12. I'm supposed to get 13. What am I missing? I didn't add the remainder yet. So 12 plus 1 is 13. I got the dividend again. That means my answer is correct. Okay, so we can draw a number bond to show 2 groups of 5 and then 1 more. Let's turn our array into a tape diagram. So if you look, we have 2 groups of 6 with a remainder of 1, and that whole tape diagram equals 13. This tape diagram shows 13 roses divided into 2 vases. Can you make a tape diagram showing 13 roses divided into 4 vases? Go ahead and pause and see if you can figure out how to do this. When you're ready, you may move on. Okay, so if I have 4 vases, well, how close can we get to 13 without going over? Count by 4s. 4, 8, 12, 16. So let's see, 4, 8, 12. That's 3 times. So this is, each of these is worth 3. And that gets me to 12. I need 13 though, so I'm going to add a remainder of 1. And then this whole thing equals 13. 3, 6, 9, 12, 13. Allison has 22 meters of fabric to sew dresses. She uses 3 meters of fabric for each dress. After how many dresses will Allison need to buy more fabric? Let's represent this problem using a tape diagram together. We don't know the number of groups or the number of dresses she will make. We know that each dress uses 3 meters, so let's draw 1 group and label it as fabric for 1 dress. So we did 1 group, it's 3 meters, right here, and we labeled it as fabric for 1 dress. Now we have 22 meters that we need to get to. We don't know how many dresses she can make or how many 3s there are, so we will label that with a question mark. We do know that there will be a remainder because we know our facts of 3, and 22 isn't a multiple of 3. Solve this problem. So remember, 22 is not a multiple of 3. That means we're going to have to add a remainder. That didn't look very good. Let's just add a remainder right here. Okay. So go ahead and try to solve the problem. Can we do this? 3, 6, 9, 12, 15, 18. I made these too big. Let's try this again. Let me make them smaller though. Get rid of this thing too. Okay, let's start this over again. 3, 6, 9, 12, 15, 18, 21, and then we know we have a remainder. So we know we have 21 with a remainder of 1. So how many 3's do we have? 22 divided by 3 equals 1, 2, 3, 4, 5, 6, 7. So the question is, after how many dresses will Allison need to buy more fabric? Allison is going to have to buy them after 7 dresses because she can only make 1 with what she has left. There are 19 identical socks. How many pairs of socks are there? You're using the read, draw, write process. So you're going to read it, draw it, and then write it. So there are 19 identical socks. How many pairs of socks are there? Will there be any socks left over without a match? If so, how many? If you enjoy solving the tape diagram way, you can do it that way, or you can do it the array method, whichever method you prefer. Now, I know that socks, it says pairs, but I know that they come in twos unless you have 3 feet. So we're going to go by twos. We're going to count by twos to get to 19. So 2, 4, 6, 8, 10, 12, 14, 16, 18, and one more makes 19. So how many pairs do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 pairs with 1 left over. Now I could have done this using the tape diagram method. We know that this whole thing is going to equal 19. 2, 4, 6, 8, 10, 12, 14, 16, 18, with 1 left over. So whichever method works best for you, go ahead and do that. This number 2, it takes 8 inches of ribbon to make a bow. How many bows can be made from 3 feet of ribbon? 1 foot equals 12 inches. Will any ribbon be left over? If so, how much? So we have 8 inches of ribbon. How many bows can be made from 3 feet? Well, it says 1 foot equals 12 inches. So what's 3 times 12? Because we have 3 feet times 12. 3 times 12 is 36. So we start with 36. And every ribbon we make takes 8 inches. So how many ribbon can we use? How many bows can we make? And will any ribbon be left over? If so, how much? Okay, the rest of it you should be able to do on your own. I think it's pretty easy.